Hello viewers, welcome to K Diagnostics, Dio here. Today we have a 2003 Chevy Express 3500 with a 6.0 liter. The complaint on this van is the battery light remains on while the engine is running. And the driver also stated that he has to jump start this van every other day. Sometimes when he comes to the van in the morning to start it, it doesn't start. He has to jump start it to get the van to start. So the first thing we're gonna do is we're gonna go inside the vehicle and confirm the complaint. We're gonna start the engine and see if the battery light is gonna remain on the dash. After confirming the complaint, we're gonna connect a scan tool to the vehicle to scan the engine computer to see what kind of trouble codes we have in the engine computer. After we pull out the trouble codes, hopefully we have a trouble code that will give us directions on how we're gonna fix this problem. So now let's go inside the vehicle and confirm the complaint. I'm gonna start the engine. Let's see if the battery light is gonna remain on while the engine is running. The driver said that the battery light over there is coming on and off intermittently while the engine is running. So let's see. The battery light is not coming on, but the battery gauge over here, the charge level gauge, is a little bit low. Let me zoom you guys in so you can see. Okay, so we're a little bit low over here. So it looks like we have a problem in the charging system. If everything was good on the charging system, this gauge was gonna be at 14 or above 14 volts. Since it's below 14, I believe we have a problem here. Okay, now since we don't have any other lights, I'm gonna get a scan tool connected. Let's scan the engine computer to see if we have any trouble codes in memory. If we don't have any trouble codes, we're gonna go after the charging system. So I'm gonna turn off the engine. I'm gonna turn the key back on. I'm gonna get the scan tool connected and then I'll bring you guys back up. All right, I got the scan tool connected. Let's see what we got. Before we scan it, let's check the voltage over here on the scan tool first. So we are reading 11.7 volts. Now I'm gonna start the engine. On a good charging system, while the engine is running, we should have a voltage between 13.5 and 14.5, okay, with the engine running. And with the engine off, we should have about 12.6 volts. So watch that. I'm gonna start the engine and let's see what happens. This voltage should increase if the charging system is good. So as you can hear, the engine is running, but our voltage did not change. Okay, we are stuck. Well, so it was stuck at 11.6. Now it went up to 12.1, and still 12.1 is low. Okay, let me rev it up a little. Okay, that's a problem. Actually, let's scan this. Let me turn off the engine. Let's turn the key back on. So this is a Chevy. It's a 2003. Okay, so the scan tool has identified the vehicle. Let's go to the engine computer. This vehicle has a throttle cable, so we're gonna click on with throttle cable. Let's go to engine. Let's go to codes. All powertrain codes. So no fault codes present, okay? We don't have a trouble code. So now my next step is gonna be looking at some data. Let's go to data display. Let's go to engine data. So right here, ignition. So we're gonna select, let's select this ignition data PID. So let's deselect all. We're gonna grab this ignition data PID. So as you can see, we're reading 11 volts, okay? So now I'm gonna start the engine. On a good system, this voltage should have gone up, okay? Now, this tells me that our charging system is not working because our voltage is really low at idle. Okay, now this is not a battery problem, because if we had a battery issue, this vehicle wouldn't have started. Since the vehicle started, this tells me that our battery is good, but the alternator is not doing its job. Okay, we either have an alternator problem or an alternator wiring problem. Okay, there could be a problem in the alternator wiring or the alternator itself. So we got to do some tests to figure out if the problem is the alternator or the alternator wiring. And I'm pretty sure that we're not dealing with a bad battery over here. Okay, we can still check the battery, but I'm sure the battery is good. Okay, so we have 11.8 volts at idle. So this is abnormal, guys. And this is what's causing this vehicle to require some jump starts every other day. I don't even know how they drove it for a couple of days without the battery dying. So I'm pretty sure this charging system is failing intermittently. Maybe at times it works, at other times it doesn't. Okay, so I'm gonna turn off the engine. So we know that our charging system is not working because we have 11.8 volts while the engine is idling, which is abnormal. So now what we need to do is we have to go to the battery and measure our voltage at the battery. We're gonna measure the voltage at the battery first with the engine off and then with the engine running. And after that, we're gonna go to the alternator and do some testing at the alternator. But before we go outside, I'm going to back out and I want to quickly look up the charging system on this vehicle. So let's go to service info. I want to familiarize myself with this alternator and see how it's wired. So this is a 3500 Chevy. So right here, guys, this is the alternator, and as you can see, this is our B positive terminal of the alternator. So this is the power supply wire at the alternator, and this wire is coming from the battery. Okay, so we're gonna have positive here, or 12 volts all the time on this wire, and then these other wires over here are coming from the computer, this orange wire and this gray wire. So these are the control wires. Probably one of them is going to be the control, and then the other one is going to be the feedback to the engine computer. Okay, so basically what we're going to do here at the alternator, we're going to make sure there is power over here on this wire, and then we're going to do a voltage drop test on this positive wire of the alternator. If this wire over here passes the voltage drop test, the next test we're going to do is going to be the negative side of the alternator voltage drop test. Now, when we do the voltage drop test on the positive side of the alternator, the number we're going to be looking at is going to be around 200 millivolts. Okay, nothing above 200 millivolts. And we have to basically use a multimeter. We're going to connect it to this side of the battery and this side of the alternator. We're going to start the engine to see what voltage we're going to have here. If we have a voltage above 200 millivolts, that will tell us that there is high resistance on this wire. Okay, and then we're going to do the same thing on the ground of the alternator. The alternator is grounded through its case. It's grounded through the engine block. We're going to use our battery ground, so we're going to use a multimeter. We're going to connect one side of the multimeter test lead to battery ground, and then the other side of the multimeter test lead to the alternator case. We're going to start the engine to see what voltage we're going to have on the multimeter, and that voltage shouldn't be above 200 millivolts as well. Okay, and then we're going to use a lab scope to test these two wires that are coming from the computer. If the wiring tests out okay, then the problem is just going to be the alternator. I'm suspecting the problem is the alternator, but we are not just going to replace the alternator without testing the wiring first. Okay, so now let's go outside the vehicle and do that. Here is our battery compartment. So since this is a small bus, I mean it's a van front end. Okay, now we got two batteries on this vehicle. So what we're gonna do is we're gonna use our multimeter to test the battery. So I'm going to connect my negative lead of the multimeter to battery negative, and then my positive lead to battery positive. We're going to turn the multimeter on. So as you can see, we are on the voltage scale. Now this voltage is a little bit low because the alternator wasn't working. Okay, at the battery we should have at least 12.6 volts, but I'm sure these batteries are good because these batteries were replaced not too long ago. Okay, these batteries are good. The problem is the charging system. So right now with the engine off, we have 11.75 volts at the battery. So if the charging system is good, after I start the engine, this voltage should increase. So now let's go inside the vehicle and start the engine. Then we're gonna come back here to check this voltage. All right, so let's start the engine. Let's go back and check our multimeter. All right, so with the engine running, the voltage went slightly up. Now we're reading 12.16, so it's kind of fluctuating, 12.19 volts. So this tells me that our alternator is not putting out enough voltage to keep these batteries charged. Okay, so now the next step is going to be going to the alternator and doing some tests at the alternator. So now let's go under the hood. Alright, so since the battery is on the frame on this vehicle, what I'm gonna do is I'm gonna get jumper cables. We're gonna connect them to the battery and bring them over here under the hood so we can do our test, okay? Because we're gonna do a voltage drop test. We have to connect one side of the test lead on the multimeter to the alternator over there, and then the other side of the multimeter test lead to the battery. Okay, now I'm gonna grab a good set of jumper cables so we can do our test. So we're gonna use these jumper cables over here. So these will allow us to have a good connection from the battery to the alternator. So our red test lead is gonna go to battery positive. So we're gonna connect this over here. And then our black test lead is gonna go to battery ground. Okay, so we're good here. We got good power and good ground coming from the battery. So now we're gonna take this under the hood. Okay, so we know we got good power here and good ground over here. So now the first thing we're gonna do is we're gonna do a voltage drop test first. Okay, now my multimeter is on the voltage scale. Now what I'm going to do is we're basically gonna connect our multimeter in series with whatever side of the circuit we are testing first. So I'm testing the positive side of the circuit first, of the alternator. So I'm gonna connect my positive lead, so black lead, to battery positive, because this is coming from the battery. Let me see if I can make good connection here. Okay, so battery positive here. Okay, just to check our connection, if I touch ground with this black lead, we should read battery voltage there. So let me try that. Touch ground. As you can see, we're reading 11.93 volts. Okay, so we are making good connection on our positive side of the battery. So now I'm gonna grab this black lead. I'm gonna connect it to the B positive terminal of the alternator. So the B positive terminal of the alternator is this stud over here. Actually, this wire over here, this red wire. Let me move this wire loom so you can see that this wire here is red. Okay, this red wire is what brings battery voltage to the alternator. So now what I'm gonna do is I'm going to use this black lead of the multimeter and connect it to the B positive terminal of the alternator. Okay, so we got that connected there. Now with the engine off, we're reading 0, so I am going to start the engine. You have to do this voltage drop test with the engine running, okay? And ideally you also want to load the circuit. You want to load the charging circuit so you can turn on the headlights, the fan inside, I mean the blower motor, and the radio. So right now we got 0. With the engine running, our measurement or the voltage drop shouldn't go above 200 millivolts. Okay, so now let's start the engine. So let's get the engine started. So the engine is running. I'm gonna turn on the headlights. Let's turn on the blower motor as well. Alright guys, so check that out. We have minus 1.90 volts. This is a problem, guys. This is a big problem, okay? This here is a problem. We have high resistance on the positive side of the alternator, okay? Actually, we have a negative number. We have a minus sign over here because our test leads are flipped. If I turn off the engine and put our positive on the multimeter, on the alternator, and then the ground over here, we will have 1.87 volts. So 1.87 volt is a lot, okay? That's high. There is high resistance on the positive side of the alternator. So this is the problem. This is why this vehicle is not charging the battery, because there is high resistance on the positive side of the alternator. So the alternator is most likely good. The problem is high resistance on the positive side. So let me turn off the engine and switch these test leads. We're gonna do the same test again, and then we will do the other test. If the other test out okay, we will come back to the positive side of the alternator and figure out where the high resistance is. So now let's go back in the vehicle and turn off the engine. Alright, so I'm gonna move this red test lead to the alternator just so we don't have a minus number on the mirror anymore. Okay, I mean this is not really necessary, but just to show you guys, just to show you that I had my test leads backwards. Okay, so now we have our positive lead of the multimeter on the B positive terminal of the alternator, and then our negative lead on the test lead or the jumper cable coming from battery positive. Okay, so right now, as you can see, we are reading 0. Let's go inside the vehicle and start the engine. So the engine is running. We're gonna turn on our headlights. So what do we have here? Okay, 1.87 volts on the positive side of the alternator. There's your problem, lady. So this is the problem, guys. Okay, a good voltage drop number on a good circuit should be anything below 200 millivolts. Okay, anything above 200 millivolts is too high, and as you can see, we have above 1.8 volts. Man, that's crazy. Okay, so this is the problem. So now what we're gonna do is we're gonna do our voltage drop test on the negative side of the alternator now. Okay, so we did the positive side of the alternator. We know there's high resistance on the positive side of the alternator. So now we're gonna do the same test on the negative side of the alternator. I'm gonna turn off the engine so I can show you how I'm gonna set that up. All right, so the engine is off. So now we're gonna do the same test, but this time on the alternator ground. Okay, now the alternator is grounded on its case. Okay, so I am going to move my test lead over here from the B positive terminal of the alternator. We're gonna move it to the alternator ground. Okay, just right there by the alternator bolt. I hope you can see right there. Okay, so I got my test lead right there by the alternator bolt. So that should be alternator ground. Okay. Now we're gonna move our black lead of the multimeter. So we're gonna remove it from battery positive. Now we're gonna take it to battery ground. So basically just the same thing we did on the positive side. Okay, so positive side you go positive to positive, and negative side you go negative to negative. Okay, so right over here we got black lead of the test lead going to battery ground, and then red lead of the test lead going to alternator ground. Okay, so now let's go inside the vehicle and start the engine. With the engine running and the charging system loaded, our voltage reading on the multimeter shouldn't be above 200 millivolts. So now let's go and start the engine. Alright, so the engine is running, the headlights are on. Now let's go check out our multimeter. Okay, so with the engine running and the charging system loaded, we are reading minus 0.00 volts. Okay, so we don't have voltage drop on the ground side of the alternator. Actually, I can just switch these test leads over here so we can get rid of that negative number. Okay, so right here we got 0.01 volts. So this is good. Okay, this is what we should have seen on the positive side of the alternator. Ideally you want to see 0.01 volts. So we don't have any voltage drops on the ground side of the alternator, so that's good. So now the next step is going to be testing the other two wires at the alternator connector. Okay, we're going to test those two wires and make sure that the computer is controlling the alternator. If we have our controls there at the alternator, then we're just going to go back to the positive side of the alternator and figure out what's causing voltage drop. Okay, so now I'm going to turn off the engine so we can get our lab scope hooked up to the two wires that are coming from the computer at the alternator. So we're going to use our lab scope to test the other two wires at the alternator. I'm going to get our lab scope set up and connected to the other wires that are coming from the computer. After I get everything set up, I'll bring you guys back up so we can do the test. I got my lab scope connected to the two wires that are coming from the engine computer. Okay, so these two wires over here at the alternator electrical connector. Okay, the gray wire and the orange wire. So we're gonna use two channels on the lab scope. So now let's get our lab scope set up. Let's go to scope multimeter. Let's go to lab scope. Okay, so we only need to keep 2 channels turned on. Let's stay on the 20 voltage scale. Okay, so we're gonna turn everything off. Filter, everything is off. So right now, with the key off, engine off, we got about minus 0.02 volts on the yellow trace and 0.01 volt on the green trace. Okay, so now I'm gonna go inside the vehicle and turn on the key first. Any voltage that we're gonna have on these traces will be coming from the engine computer, because those 2 wires at the alternator are coming from the engine computer. So now let's go turn on the key. Alright, so look at what we got. So let me decrease our time base. Okay, we have some type of activity over here. Let me turn off the blower, it's loud. So now we have about 1.25 volt on the yellow trace and 1.24 volt on the green trace. Okay, and the max on the green trace is 5.31 volt, and then the max on the yellow trace is 1.70 volt. So this tells me that our wiring from the alternator to the engine computer is good, because this on and off control that we have over here on the lab scope screen is being generated by the engine computer. Okay, so this on and off voltage control over here. So now I'm gonna go inside the vehicle and start the engine. So check this out. The engine is running. It looks like our voltages went up. Okay, so the yellow trace went up to about 9 volts. I'm pretty sure this should have gone up to system voltage, I mean the yellow trace. And then the green trace went up to so it's kind of fluctuating, but 3.41 volts. Okay, and look at this. So the yellow trace at some point when we first started it went up to 13.79 volts, which is good. Okay, but on the scan tool right now we're still showing 11.9 volts. So this is a classic symptom of high resistance in one of the alternator wires, and in this case we have high resistance on the positive side of the alternator. Okay, so the computer wires are good. This is good control coming from the engine computer. The engine computer is definitely controlling the alternator. So our green trace is the computer control, and then the yellow trace is the feedback to the computer. Now let's turn off the engine again. Okay, I'm sorry we are going back and forth. So we are good here. So let's look at our wiring diagram again. So here is what we did. We did a voltage drop test on the ground side of the alternator. The ground side of the alternator is good. There is no high resistance on the ground side of the alternator, but we have high resistance on the positive side of the alternator, because when we connected our multimeter from battery positive to the B positive terminal of the alternator with the engine running, we had about 1.86 volts on the multimeter, which told me that there is high resistance on this leg of the circuit. So this is what's causing this alternator to not charge the battery. Okay, so the battery is good. The battery over here is good. The alternator is good, but the problem is this wire. So we have to figure out where our high resistance is. We could have high resistance here at the battery, or we could have high resistance over here on this bolt at the alternator. Okay, so Now what we need to do is, I'm gonna get all these tools out of the way. I'm gonna show you that high voltage that we have on the positive side of the alternator once again, and then I'll tell you what we're gonna do next. I'm gonna show you that high voltage drop reading that we have on the positive side of the alternator once again. So we have our red test lead coming from the multimeter connected to battery positive, and then our black test lead coming from the multimeter is connected to the B positive of the alternator. Now you will see when I start the engine, we're gonna have about 1.80 volts of voltage drop on the positive side of the alternator. So now I'm gonna go inside the vehicle and start the engine. So right here we have 1.69 volts. This is a lot, okay? This is a lot. So this is the problem. Replacing the alternator on this vehicle wasn't gonna fix this, okay? Because this alternator is good. This is the problem, okay? High resistance on the positive side of the alternator. So now we need to trace down this wire from the alternator back to the battery, okay, to see. We could have a defective cable. The cable could be bad, or we could have corrosion on each end of the cable, okay? So over here at the alternator or at the battery, okay? So this over here is the problem. Now, since it's easy to get to the battery, I'm gonna turn off the engine. We're gonna start by checking our connection at the battery first. We're gonna clean off our connections at the battery, and then we're gonna come back here and start the engine and watch this reading and see if the reading will get better, okay? So now let's go inside the vehicle and turn off the engine. All right, the engine is off. Let's go and start with the easy side at the battery. All right, so we're gonna get these disconnected. So here's our positive side of the battery. So let's undo this first and look at it. So this end doesn't look too dirty to the point where it's gonna cause a lot of voltage drop, but I'm gonna clean it. Although we didn't have voltage drop on the negative side, but I'm gonna clean both of them. So let me remove the battery. Let's get the battery out. Actually, there is something I see over here. What is this? Oh, check this out. So what happens is we have power coming from the battery, and then it goes to this device over here. I don't know what this is. And you see how corroded this is? This looks like some type of inverter.